So let's take a use case where you work in a company. Let's say you work at Amazon, and this is an actual use case. In fact, instead of Amazon, let me just tell you the use case of Uber, right? Um, if there is a ride, there's this rider here, right? Uh, they did not find the ride comfortable, or they found the ride to be unsafe, or something is wrong with the ride, because of which they want a refund from your system. And I'm just taking an example of the Uber system, but this is common in many organizations. There's Swiggy, there's Zomato, there's DoorDash. Many of these systems deal with upset customers using refunds, because this is something that happens all the time. You're going to take like maybe 1,000 Uber rides in your lifetime, so they don't want to lose you. The way they deal with complaints is just by giving a refund default. Now, if you're not satisfied with the refund, or if the system chooses not to refund you, very often what happens is there's an escalation to a human, right? This human just has a torso, they don't have legs. Okay, I'll just give them legs and hands also. But this human has to now manually look into this escalation and either decide to refund or to say no, this is a case of fraud, or we don't believe in a refund at this point. How expensive do you think this is as compared to a system generated answer? Any guesses in the chat? And give me a multiplier. So if this is, let's say, x and this is y, what's the relation between x and y? What do you think x is in terms of? Is it 10 times y? Is it 20 times y? Is it 100 times y? Is it 2 times y? What's the number like? Any guesses in the chat? Okay, is the situation clear? When you are buying anything or selling anything, I'm sorry, when you're buying something from a platform or a system, you may have complaints, and those complaints are usually auto satisfied or auto resolved. But there are times when you have to escalate this to a human, and the human needs time, which costs money. So yeah, okay. Now look at that. A lot of you are expecting 20x and 10x. I think I've also I've also biased you towards very large numbers. The reality is 7x. Okay, 7x. And 7x. Okay, 7x. In fact, let me change that. We talked about the cost of human generated versus automated. Okay, what's the price of x going to be like? That's a good guess. Many of you are given 20. The profit generated from a ride is, let's say, $10. That's the profit, okay, for the platform. X is then $70. That's how expensive it is. The profit margin may not be $10, maybe $1, right, for Uber. But then the cost, the support cost is like $7. So it's crazy. Just to keep a reputation, just to give good user experience, companies like Uber and Zomato, DoorDash, they are ready to spend all this money, 7x the profit margin of a single purchase. It's huge, okay? And that's the reason why in many of these companies which are operations heavy, you're going to see a movement where they take the system generated automated answer and try to improve on it. This part is burning cash. Okay. Anytime there's an escalation, this is going to cost you, so you want to avoid this escalation. And the only way you can avoid that escalation is by making this model intelligent, by reducing the probability of it making a mistake. Okay. Is the business use case very clear? It's extremely expensive to escalate problems to humans. The reason we escalate problems to humans is because they are intelligent. If part of that intelligence can be put into a system, then we are going to be making much larger profits. Okay, and that's the reason why you'll also see in the engineering blogs of Uber, they are going for AI heavily. Even Swiggy, Zepto, a lot of these guys are trying to build AI into their systems because they are very, very operations heavy, and so the cost is a big factor. It eats into their profits. Anish has a very interesting point. Yeah, there's training cost here also. There's training cost, hiring cost. You have to keep two people. I mean, if there's a support query which comes in, you have to build a queue over here. Here, you can say that it's going to be immediately answered in seconds. So yeah, in every way, this is like super expensive. It's not a very good customer experience also at times because it takes time. Anshuman, the way we are calculating cost is how much money do you spend on them versus how much did the ride actually pay you. So if this paid you $1 and the support query cost you $7, then 7 rides are no longer useful. It's as good as taking 7 rides and throwing it into the dustbin, the profit. So it's huge. This is just a use case. I'm just coming up with numbers, but I did work at Uber, and I'm not telling you the exact numbers, but this is a roughly ballpark. Okay, and I used to work there 5 years ago, so things have changed, of course, but it's like super expensive. Okay, so now that we know why we are doing this, let's go to the tech. Okay, the way to manage this earlier on support was to actually have people, train them, and give them a large number of dashboards that they can use to answer queries. So when there's a human, what do they need to answer queries? They need information. They need to know that this rider, I'll just use a different color here. Okay, this is the flow of the rider has a ride. They don't like it, they ask for a refund. The system then goes and connects to some sort of data store and gets information on the ride. It either automatically resolves it or it escalates to the human. We'll now make this a two-step process. We will either auto-resolve. If not, we are first going to try to escalate it to some sort of intelligent AI, which will have its own data store. And if this doesn't happen, so number one, just do things automatically. Number two, send it to AI and the AI can respond for you. And number three, if things go really, really bad, then we go to the human and the human can still do the manual processing, step 3, of the refund or no refund. Okay, so original process has been made even more powerful by just adding a new step where instead of escalating directly to the human, you can escalate to AI. What is the AI for us? It's obviously a large language model. Okay, so instead of talking to a human being, you are now talking to a chatbot. This is nothing new. Okay, this is like standard. But there's one interesting thing now with this RAG. Can anyone tell me in the chat, this is for the next 2 minutes till 9:20, how do you make a large language model which is reasonably smart answer customer queries which are specific to a particular ride, specific to a particular purchase? So guys, we are not going to use MCP here, not yet, because MCP for Uber does not make sense, right? MCP is in case you have multiple systems which are, so we'll get to MCP later anyway, but MCP is not what we're going to use here. We are going to use a simple vector database. And what is this vector database going to store? It's going to store company documents which you used to use to train your customer support team. When they would join your organization, they would take like 3 months, let's say, or however long, maybe 3 weeks, to upskill themselves with these documents. So depending on the situation of a refund or unsafe driving or something else, you have various documents which tell you the protocol, which tell you how to answer these queries. Instead of having a human being trained on this, or okay, you have had the humans trained on it, also train the AI model on it. But can you really do this? Can you build your own model if you're a medium-sized organization or even Uber-sized organization? It doesn't make sense. You would much rather use an external system of OpenAI or Google, which will have the LLM for you. What you want to do is you want to take these training documents, and depending on the customer support query, so this is step one, you have customer support query, step one. You want to find the document which is most relevant to this query, or the set of documents which are most relevant to this query. And step three, forward this to a large language model. The expectation is that the large language model will answer the query, step 4, with relevant context from step 2. That's the idea. And this has taken the world by storm, the engineering world by storm, because many support queries, many search queries, many recommendations can be managed entirely through this flow. Take a query, find relevant documents, you send the query and the relevant documents and the system context to an existing open large language model, and what do you get? You get a response which is far better than the plain vanilla response. I'll take an example, and this is like a made up example, but it should explain to you where I'm coming from. Let's say you say, I want a refund as a user. This is it. This is the only text you have sent. This might also be automatically generated depending on your button click. The model has context of when you took the ride, so all ride details. It has your previous history, so customer history. It has general refund agreement. It also has the refund policy. It takes all of this stuff and it sends it to a large language model. The large language model has some sort of a tiny brain, you might assume, and this decides whether or not the refund should be accepted or rejected. Okay. If you can give it relevant context in this case is documents and data, then the large language model will be able to come up with superior responses than plain vanilla responses. A vanilla response would be, oh, I feel really sad about this, maybe I should give you a refund. But if you know the right details, if you know the customer history, if you know the agreement and the policy, then you'll be able to make a much better decision. Okay, much better decision with context. Now the question is, where do you get this history from, or where do you store all this stuff? The right details, customer history, refund agreement, refund policy. Okay, customer history can be fetched from some sort of a microservice, maybe for users. Ride details can be fetched from some other microservice for rides. Refund agreement and refund policy. How can a system confidently say that this query, which has the word refund, is going to be related to these two documents? These are documents, docs, and this is data. Okay, how do you find documents related to a query in real time? Yeah, Nikunj, you're absolutely right. It's some sort of a data store, and a vector data store is exactly what you're looking for. Jayesh, you also hit the nail on the head. We are looking at a vector database. Why? Because you know that documents or any kind of objects, when they have an embedding, when you convert them into a vector, we are basically able to encapsulate the properties of this document in an n-dimensional space. We spoke about two-dimensional spaces where you have some property here, x and y, like For example, the document, how related is it to refund? The more related it is, the more on the right it goes. And the second one is how lengthy is the document. So the more context it has, the higher up it goes. So this would be its company policy. And this would be, let's say, policy for India. And this would be specific policy for China, and so on. So the vector database stores these in an n-dimensional space, such that for any input query, when you take the query and convert it into a vector, it ends up lying. So let me use a different color. When you convert this into a vector, it ends up with all the nearby relevant documents close to it in the n-dimensional space. Their Euclidean distance or their cosine distance is low. That's the property of vector databases. Take the documents, convert them into vectors. Wonderful. You have an n-dimensional point. Take a query, convert it into a vector. Guess what? It's close to the n-dimensional points which are related to it. Okay. How is this useful? Because you look at these n-dimensional points and you say, all right, let me fetch the corresponding documents. I have all relevant documents now. I can feed this to the large language model, to OpenAI, to Google, and it's going to give me a really good response. That's the core of vector databases in RAG. And this is actually the end of a vector database, which has all vectors for your company documents in our case. Okay. Yeah, that's a really good question, Akash. Isn't this semantic search on a vector database? Exactly. So if you're Netflix now, we just jumped from Uber to Netflix in a second, but you see how powerful these models are. They're being used across. Netflix is trying to build its own foundational model, by the way, now. And look at the use case for Netflix. I need to find movies which a person or some entertainment that a person is likely to watch. If I can take this user, this entire user, and map them in the vector database as a point in this n-dimensional space, as long as I have the movies in this n-dimensional space which are close to them, I take this, I have some sort of threshold like, okay, the cosine distance should not be greater than 10. I take these movies and I show them as recommendations to the user. And the user is going to love it because these are the kind of movies that they like to watch. Okay. That's the power of vector databases. They work for search. In our case, in the case of, let's say, fictional case of Uber, they work for company documents, but they also work for recommendations. A lot of this has come to light. Okay, that actually explains how RAG is taking over dashboards, is taking over basically humans in the customer support area. Okay, earlier even recommendations used to be auto-generated. Even before that, there used to be dashboards. Now the manual step is being augmented with retrieval. Mihir is asking, how do we actually get data from the vector database? So that's a good question. You have standard algorithms. I won't get into them because they are a little detailed. So how are vectors indexed and how are vectors compressed? How does similarity get measured? These are things I have taken in the course, and it will take a little while to come out. But yeah, you can have them. You can have a look over here. At this point, we are focusing more on the software engineering side, not on the internal algorithms. Those are mentioned here. VectorDB. Okay, let's move to the second part of this class, which is MCP. MCP stands for Model Context Protocol. Okay, and just the use case. Let me take a different use case. Maybe this is a little confusing. The case of agents, aha, and more specifically, you have Make My Trip. Okay, so You want Make My Trip to not just give you recommendations, which can be satisfied using RAG. You don't want it to just give you advice or reviews. Okay, TripAdvisor, Make My Trip, all of these websites which help you plan trips as a user. What you want to do is ask the platform to go and book the hotel which it really recommends for you. Okay, block your calendar, set up an automated email response that I'm sorry, I'm out of office right now, or I'm traveling. Book flights, potentially book the Uber when you have landed there, or book a cab, and maybe book the itinerary or things that you're going to do. So if you're going to travel in that city or in that place, take care of that. A lot of bookings and some calendar blocking, automated response, so on. If you want this model to not just give you advice, recommendations, reviews, and so on, and actually perform actions, action 1, action 2, action 3, and so on, and actions, you're looking at some sort of API call from the large language model. Okay. So it just doesn't give you text, it actually gives you commands. That's the whole idea of model context protocol. As long as you're able to read the text of the large language model, things are fine. You give that back to the user. But along with that, you read commands in some structured format, and you're able to execute those API calls, execute those commands for the large language model. The responses then are taken by the large language model maybe, and they are used for further processing till you get a final output. This is sent back to the user. The quality of this response is not the question. The quality is as good as earlier. But the effect is that you're able to take actions as a platform with some sort of intelligence. You no longer have to manually write things that, if a person is going on a trip, then book their hotel, ask their permission, do this, do that. No. The model is taking care of that for you. It's like a flow. Things are happening behind the scenes, and the user gets a much better experience. From time to time, you might ask them permission, I need your credit card number, I'm booking this hotel, do you find it all right? But now the user does not have to manually scan through all the hotels in the world. The large language model has selected the best hotel for them and maybe gives them 2 options. It's so much easier because the intelligence is now in the system. Before that, this was a dumb system. Now the intelligence has made it really smart. Is this making sense? The intelligence is coming from the large language model. Context is coming from RAG, vector database sources, and the action capability is coming from MCP. This is the reason why MCP and RAG are taking over, because they have just so much capability in so many existing systems out there right now. Okay, so now that we know what MCP does, why it has come into the picture, let's understand its internal architecture a little bit. It's really simple, very similar to how API requests happen right now. You have clients and you have servers. An MCP client, this is not REST, this is not HTTP, this is a little different. It maintains a session with a server. The server itself can perform multiple actions behind the scenes. That is normal for any server before it comes up with a response. When the client gets a response, it can respond to the original user here, or it may hold. It may ask it to do more things, more actions, action 2. It may also ask another server to perform action 3. And after it gets a response, the client may or may not respond to the user again. So why is this so useful or helpful? These can happen asynchronously, they can happen in parallel. The user is not aware of all the things that are happening behind the scenes of this MCP client. And another benefit when I'm talking about action 2 is that this session is maintained. So if the user booked a hotel and next they want to book a flight, the MCP server already knows the city of the hotel that they're staying in. So they know exactly where the user wants to go from A to B. Okay. Unlike HTTP, which is stateless, this is stateful. Maintains a session for the user. Okay, the MCP server does that. Is there a lot more to this? No. You know, at a high level, this is it. And it's also the reason why it's become so popular. You can have, I mean, if you don't believe me, then just have a look at this. Okay, this is the basic diagram. This is the RAG part. You can get rid of this also. Local data sources, remote data sources. This is up to the MCP server. But at a high level, you just have a client and you have a server. Simple as that. Just defines the very high level protocol of how they interact with each other. Stateful interactions. And yeah, that's pretty much it. Okay. So firstly, is the use case clear, and is the high level architecture making sense? You have clients, you have servers, you have sessions being maintained, and actions that are suggested by an LLM. We are asking why MCP? I mean, if APIs existed, then what is MCP doing? It's just an API call, right? No, it's not. A large language model, when it comes up with suggestions or advice, is going to require some action performance also. Okay. Currently, large language models cannot perform actions. They cannot send emails. They cannot go and fetch data from an API. They cannot go and do a post request to some other external server. It's not possible. Large language models can't do that. So if you want them to perform actions, not just give advice, you need a way, you need a protocol that is going to allow them to do that. Okay. That is what MCP is doing. Right now, you can try to go and tell a large language model, hey, just send an email from my side. Here's my OAuth. It's not going to happen. MCP is the thing that is defining it. And why is it a big deal? Because the large language model has intelligence. It comes up with very good consolidated responses. And then it also wants to perform actions in some of those responses. Okay, if you very clearly tell a large language model, please book this hotel for me from this night to this night, it can't. Unless you have an MCP server which is going to allow that. Okay, who's going to, so that brings us to our question. Who's going to build these clients and servers? Who's going to build the MCP server in a booking application? The MCP server has to come from the hotel, the cab, and so on. So the hotel has its own MCP server, which has APIs for booking, which has APIs for cancellation, refund, maybe getting their policy. All of the public APIs that it has will be exposed using the MCP protocol so that LLMs can actually use them. A cab company, a cab aggregator company will again give very similar APIs, booking, maybe rating, and so on. So it will create its own MCP server, which can be used by external large language models. Google, OpenAI are going to be able to discover these MCP servers like they do with DNS. They're going to be able to discover, connect to them, and actually perform actions. As long as you're able to perform these actions through the MCP servers, it makes business sense for Uber, a cab company, or Booking.com to create their own MCP server. The hassle of me sitting in OpenAI chat GPT and saying, please book it for me, and then it says, no, I can't book it for you. Please go and open a new tab. That's not very nice. If OpenAI can do it for me, I'll be more than happy. So it becomes the responsibility of the business to create an MCP server that can be used by large language models. If they don't do this, eventually it will become such a big hassle that people will say, if you don't have an MCP server, I don't want to book using you. Okay, I don't like Booking.com if they don't have an MCP server. Because everybody else gives me a seamless experience, you don't. That's the reason why it's such a big deal now. Okay. MCP is typically API calls. Even the session that I'm talking about is basically in the order of minutes. But agents can run for hours, days, years. They're like, you can think of them as a continuous running process. So let's say you have some sort of a meeting in office today. And then you also have another meeting. And you have another meeting. 3 meetings concurrent. You have no idea which one is more important. You are the CEO of the company. Not interview ready, like a big company, For me, I know there's like 10 people. So we know exactly what's going on. But a CEO of a very large company like Google is going to have trouble figuring out which meetings are important, which can be delayed, and which can be in fact cancelled, can be converted into an email. Maybe you want to take this decision and send it to a large language model. Okay, humor me for now. I know that most of the times these meetings are important, but for now you want to figure out through some external intelligence which of these meetings is the most important and time sensitive. You do this today. Tomorrow you have a slightly different use case. Slightly different. You have a meeting. You also have a personal errand. And you have your some launch event. Okay, 3 different things. This was managed by some sort of an MCP server, or managed by you manually through LLM, which gave you advice. Is this really so different? The answer is no. This is managing your calendar, managing your actions, helping you prioritize, helping you choose. The same problem comes tomorrow. It would be nice if the large language model had context from yesterday when answering your query. And it would be really nice if your responses to the large language model were considered to reinforce good behavior and punish or discourage bad behavior. This is the core part of an agent. Okay, everything else we have already done. We know how to get data, we know how to make API calls, but this part of reinforcing good behaviors and discouraging bad behaviors basically makes the model tuned to your preferences. And that would make this a long-standing process which understands what you want to do, which has goals. Okay, that's what an agent is. Is this making sense? Are you able to look at these properties and say, okay, I know exactly what you mean? It's reinforcement learning, right? With human feedback. The previous class had this in detail, how large language models deal with human feedback. Okay, I'm rushing through this because we have discussed this last time. Please click on lecture number 4 in the description if you want more details. This is called reinforcement learning with human feedback. Okay, and this is something that agents can do. Okay. So putting it all together, RAG helps you get context, user context or situation context using vector databases. We discussed how a customer query can get a lot more useful company specific context put inside it and sent to a large language model so that the quality of the response of the large language model improves dramatically. It's able to answer customer queries better after being given the right context. We then discussed, okay, RAG is good, you know how to answer, but is that all you can do? Is answering all you can do? No. We can also take actions on what we know is the right thing. If we are confident, we take action. If we are not confident, we ask the user. But we filter, we sort, we help the user make their decisions quicker. You're going to Switzerland, you don't have to see all 600 hotels. I'll choose 3 for you. Maybe you'll find any one of them good out of the 3 and we can go ahead with the booking. You don't need to tell me your details for booking, I want it this way, that way. You'll get a notification on your UPI or your credit card that a booking is going to be made now. Beautiful. I don't even have to leave my tab, the OpenAI tab, right? After giving the capability of actions, after bringing in intelligence and giving the capability of actions, we said, you know what, even now I feel something is missing. And what's that? My preferences. Whether I like something or dislike something is not going to be managed by an MCP server, not by an external API. I want you to behave the way I want you to behave. And for that, we have agents. Discouraging bad behavior, reinforcing good behavior. Good and bad is subjective for that user. I might like very cheap hotels, you might like very expensive hotels. That's fine. The agent will learn using human feedback, which helps it reinforce its weights or its space, mapped space. Are these points clear? Are they crystal clear, or are they, yeah, I think I got like 80% of it. Whatever be the case, do have a look at these technologies. I have created videos on MCP, RAG, and agents. All 3 are quite useful. I would suggest even looking into LLMs. Guys, it's coming out in 3 days. I am super excited. If you want like a short trailer of this, you can check out this video. I have already shared the link with you on chat. Great to actually have all of you come here on a Saturday morning. And yes, something interesting for existing users of Interview Ready. If you have purchased any course at Interview Ready, system design, behavioral interviews, low-level design, you're going to be getting a special loyalty bonus here on this platform for the first 48 hours. Okay, it's just for 3rd June to 5th June, and it's a special discount only if you have purchased the course beforehand. So set a reminder, basically, would be my suggestion. So you get that extra discount for the first 2 days, and it will be awesome. Lucky is asking, can we first go to system design and DSA course? System design and DSA are very useful for software engineering interviews. This is for AI engineering. If you want to transition to that, it is, I would say, in parallel. There's nothing related to this which needs you to go through any other course. But there are 2 prerequisites. Okay, some knowledge on databases is useful, and some knowledge on neural networks is useful. The prerequisites will be mentioned in the intro itself, and those are both free. So the prerequisites will be, you can say, included. The links will be included in the course itself. You won't have any issues in terms of, is it sufficient? Do I have sufficient knowledge to start this course? You do. Okay. In System Design Simplified, the basic section, there is something which describes what a database is. Even in concepts, we have gone through database deep dive. This will be free. You can just go through this, and it is sufficient information for you to start with the AI course. I am going to be looking forward to all of you on 3rd June and beyond. If you are comfortable on 3rd June in the first 48 hours, please come over. You'll get a special loyalty discount. And for the first month, we are going to keep the price of the course as low as we possibly can, around 3,000 rupees or USD conversion. And after that, there may be a slight increase because a lot more content is going to be added in future. So I'm excited. Yeah, I'm like all set for June already. In June is just tomorrow, so 3rd June is the day. Thank you everyone for coming. Thank you for sticking around and making this a very successful session. I love the fact that we are all moving towards this new space together. There's lots of technologies, but there's lots of us also. So, and I think the future of AI, the future of any technology is going to be taken care of by software engineers. Data scientists, data engineers, software engineers outnumber data scientists and data engineers by 10:1 because we are generalists. We can manage applications, we can manage business requirements. So it's better for us as engineers to meet the new market demands by just moving forward into this new space. Thank you, and have a great weekend. Take care. Bye bye.